Hey! This is the experiment video, explanation video of the mysterious double tilt. And if this is the first video you're watching, you can click on my face for the intro video of the whole series talking about fidget spinner experiment videos and, well, why they work. So, without further ado, here's how the experiment works. First off, you got a fidget spinner. If you tilt it towards you, it's just gonna tilt towards you. But if you spin it, and you tilt it towards you, it's gonna kind of angle in a weird way. If I spin it the other way, it's gonna angle in the other way, and it like tilts. It's not because I'm forcing it to tilt. You kind of have to take my word if you don't have a fidget spinner with you. But if you have it, you can try it and you'll know it's real. Another way to do it is if you're spinning it facing you and then you kind of turn it one way, it'll turn the other way. And if you spin the wheel the other way and you want to turn it down, it'll go like, it tilts in 2 dimensions when you only want to tilt it in 1 dimension. That's why it's called the mysterious double tilt. So, how does it work? And you know, if you want to Google this online, there's a thing called the conservation of angular momentum, and basically what it's saying is that any spinning thing on an axis wants to stay there, but then if you spin it on the other axis, it actually turns, but doesn't go back to its regular axis. Basically, if you want to go to like a pure physics technical standpoint, it's pretty confusing. But if you want to think of it intuitively, it's actually pretty easy. And before I go on, I really want to show a small section by a YouTuber named Technicality, who is also a physics-ish related education channel, and has a lot better of a demonstration of the video. Just gonna play the clip.
As we saw, if it's not spinning, both of the legs of the fidget spinner go down equally, but when it's spinning really fast, it'll actually tilt on a slant. You can see that here as I push up on my side, and as a result, down on your side, the fidget spinner becomes slanted, even though you would think it would just tilt down normally.
Okay, so here's how I like to explain it. First, with this, I'm gonna quickly add 3 different colors, and voila! I've got here the fidget spinner, and I've color-coded it, labeled so that there's blue, pink, orange, both sides. It's a bit easier to see. Instead of having to look at the whole system, we're only going to be analyzing one, so it's, well, easier. And then we're having this little force vector direction thing. It basically has an arrow on it showing that if I want to push something that way, well, this arrow shows that I'm pushing it that way, just as a representation. So, here's how this is going to work. I'm going to spin the fidget spinner clockwise from your direction. Alright, so when I rotate it like this, this pink thing is going to be spinning towards me. Alright, and so when I rotate it on this axis, you're going to expect the pink thing to kind of wrap around, turn like this. The force goes down, and so when it's not spinning, it'll go like this. Right, and then it'll keep going until, well, I stop spinning it, or rotating it on this axis. But what actually happens when I spin it like this, it actually turns into 2 axes. And the reason for that, well, I'm explaining why. If I turn it this way, it's going to turn this way and this way. So, let's start off simple. Just follow the pink one. You got the force vector going down. So when I rotate it, pushes down and also pushes up on the other side, but that's too complicated, okay? So, pointing down, what happens when you point it down is that this thing is also spinning. So while this is spinning, the pink thing comes towards me, and then it pushes, kind of like a 45-degree angle. And when it comes back to the top, the pink thing's up here now, it's over here, and it's also pushing this way. And so, basically, there are 2 directions that are happening at the same time. I'm trying to rotate it while this is also rotating, pushing down. And this is kind of confusing, so I'm going to go from your perspective and kind of show it in that direction. So, here. Okay, so from your perspective, imagine this is the pink thing, it's coming towards you, this is the force vector pushing down, alright? And so, if it's flat like this, and I rotate it a bit, the force is going to go like that way, but then as this is coming up, it actually changes the game, because this is pushing this way, which rotates it not only on this axis, but on this axis. And so if you think of it as the pink thing goes down, it rotates, it pushes that way, but then when the orange thing comes back, it also pushes on that thing. And so as you push a bit more, a bit more, a bit more, each time you push this a bit more, a part of the little circle pushes down. And so every little turn like this, it also turns like this, and then this, and this, and then eventually it goes from this axis to this axis at the same time. And so I hope that wasn't too complicated of an explanation. And you guys may be thinking to yourself, why do I need to know this? And the answer is, you don't. But you know what, it is cool? It explains this thing called gyroscopic precession, which also talks about why the Earth is tilted on an axis based on the gravity. And before I go into it, you can Google it and spend days learning about it. Basically, it's cool because you're learning about the science of how the world works and how objects behave. Before I go on for a long rant, I hope you enjoy this video, and I challenge you. You have a fidget spinner, or your friend has a fidget spinner, or your friend has a fidget spinner, explain this concept to them. And if it was in any way confusing, you need clarification, you can comment down below, and I'll be glad to explain further. Hope that was informative, and peace out.